Well, thank you, everybody, and welcome to Networking Field Day here at NXTWORK. I'm actually excited to be here for actually three reasons. So one is this is our first custom tech field day, the one that I've been involved with, first custom one. And anyone who's been through some of our previous field days realize that we try to cram a lot into 2 hours. And it's like Sudheer already and other folks talk really fast, but trying to cram into 2 hours is like a chipmunk on crack. And so now we actually have 4 hours where we can actually do a deep dive and talk about real solutions to real problems. And that's going to be really exciting for us to do today. The other reason this is exciting is, Steve didn't mention it, but this is 10 years that he's been doing this. And 10 years that we've had a chance to kind of work with you guys and Tom, who's not here, unfortunately, and our wishes go out to him, to, again, talk about real solutions to real problems, and that's exciting as well. The last thing is, as you guys know, Tech Field Day for us is a time where we always announce new products. We save some of the best products for these types of events, and this is no different. So here we're actually going to be talking about a variety of different things in the portfolio, but specifically there's 2 announcements that we're going to be talking about, which is our new wired assurance announcement. We've actually brought the wired platform into the Mist cloud and the Mist AI engine. We've SaaSified it on the access and the aggregation side, as well as our new Marvis actions framework, which is actually taking a step towards self-driving. Okay. By way of introduction, my name is Jeff Aaron. I run enterprise marketing for Juniper. A little bit of an expanded role. Last time we met, I was doing the Mist portfolio, and now it includes the larger portfolio. And so I'm actually excited because we're going to focus on various aspects of that portfolio. So as we mentioned, there's the wireless piece, there is the access and aggregation piece on the wired side, and we're also going to talk about the SD branch piece as well. From our standpoint, all of this comes together in a common vision around this, leveraging AI for IT. Again, AI is an overused term, but at the highest level, it's all about leveraging automation, leveraging insight, leveraging actions to be able to make you guys do your job better, right? To be able to ultimately drive more cost savings, drive more efficiency, and drive assurance. But what's interesting is that when we're going to talk about AI, we're going to talk about 3 fundamental things that hopefully differentiate us from the rest of the industry, right? So the first thing is insight. But insight is a little bit of an overused term. Right? When we talk about insight, we're not necessarily talking about network insight, which is there, or even application insight. We're taking that one step further and talking about user insight, client-level insight. Actually, what is the user experience on the wired and wireless network? Can you set service levels around that? Can you then optimize that for the best possible user experience? So that's what we're going to focus on a lot when we talk about insight and leveraging AI to give better insight. The second thing is about automation. Again, a very overused term. Everything says everything from APIs and programmability to full AI is automation, and it's all true. But again, what you're going to see when we talk about automation, it's not necessarily just the automation required to get things up and running, day 0. We're going to also spend a lot of time talking about day 1 to day 365. What are all the other things you need to do to automate so that operations are effective, they're predictive, they stay ahead of the game, so that you can contact users before they call you, is kind of an example that we like to provide. And the last area is action, which lends itself to the announcement we have today. So when you have all this insight, you have all this knowledge, what do you do with it? So whether it's actually self-driving, where you can actually turn your network on autopilot, or whether it's what we call driver-assisted, where we can tell you exactly what actions you need to take to go fix the largest problems in your network, and then loop back and tell you, did you actually fix those problems? That's what we're going to be talking about, and that's what we're demoing, and that's what we're announcing today is our Marvis Actions framework. And again, in our belief, you cannot do this without AI. And again, the ultimate end game here is just better network reliability, cost savings, as well as better value both to the business and to the end user. The other thing that really makes Juniper unique that we're going to hammer on throughout the course of this session is there's actually 2 things. One is the breadth of the portfolio. So again, we're unique in that we do have that wired and wireless piece covered on the access side. We do have the SD-WAN solution. We do have a data center solution as well as a security overlay that's as robust as anything in the industry. But perhaps more importantly is we have the vision to unify all this. There's no conflicting products. There's no conflicting business units. There's no conflicting management systems. Our goal is to bring all this together, to ingest it all into a common AI engine so you have automation and insight and actions across the full stack. I think that's one of the things that makes us unique, and we're going to talk about some of those different solutions. And the other thing that makes us unique is the pillars that make an AI solution. And we keep hammering this home in MFD and other types of tech field days, is that these are the areas that really differentiate. So number 1 is the data, and we're going to do a lot of talking about this, is how you actually ingest data into an AI engine. So whether it's the fact that we rewrote the control plane and our access points are collecting over 150 user states every couple seconds and moving that asynchronously to the cloud, to how we're pulling in Juno's telemetry data from the switches and ultimately some of the edge devices. It's all about the data, not necessarily the quantity of the data, but the quality of the data. And we're going to talk about how that really makes it unique for AI. You know, the Bob Friday quote is that you can't make good wine without good grapes, or you can't do good AI without good data. And he's going to spend a lot of time talking about that again. Then there's the domain expertise. So as we said, the breadth of product and knowledge that Juniper brings to the equation really helps us differentiate there. Then it's the data science, the toolbox, the algorithms that you use to actually take that information and make meaningful insight out of that. So on that end, we've been doing this for 4 or 5 years. In some instances, we're on 4th generation data science algorithms. In fact, we have our lead data scientist, Jishing, here, who's going to come up and actually talk about some of those algorithms and how that, we've kind of come to where we are today. The 4th area is the virtual assistant. We call that Marvis, Marvis Virtual Network Assistant. So this is the ability to actually ask a simple language question and have the system give you an answer and give you specific recommendations on how to go fix this. In my opinion, this is the single biggest thing that really makes this AI. You can argue machine learning isn't AI. You can argue data science isn't necessarily AI. But when you can't necessarily tell the difference between a computer and a human, or you have an RF scientist sitting next to you where you can ask questions, that is the epitome of AI. And the last area, again, is what we're announcing today, is we've taken that Marvis VNA framework and expanded it. So now we've gone into a self-driving mode, where again, we can fix things for you if the end user wants us to do that, or we can go into driver assist mode, where we give you specific human actions that you should go take, or we think you should go take, to correct your wired and wireless problems. So real quickly, the good news is we were acquired in April by Juniper. Mist was acquired, and the synergies are really taking hold. So many of you folks may not be aware of this, but the Juniper business is a $1.5 billion, north of $1.5 billion enterprise business. And so we continue to see strong growth, double-digit growth, quarter over quarter. And obviously on the Mist side, we're seeing triple-digit growth. So there's a nice synergy together on how we're growing. And what we're talking about is it's not just the quantity of the logos, it's the quality. 3 of the Fortune 10 are using Mist, and if you actually look at some of the Juniper stuff, it's closer to 10 of the Fortune 10. 30 of the Fortune 500 are using Mist, and it's something like over 40% of the Fortune 500 are using Juniper. So there's definitely a lot of synergies. And another interesting data point is, of the last 100 trials that we started in the last couple of weeks, of those 100 trials that were started for Mist, 80% of them also include EX or SRX. So it's a great thing that we're seeing now, that there's a nice synergy and pull-through from Juniper and Mist and vice versa. So it's definitely taking hold. So what do we have in store for you today? Final slide for me, and then we'll get to the guys that really matter. So as we said, we are going to talk about the evolution of our AI journey. And in particular, there's 2 announcements that hit the wire about an hour ago or a couple hours ago, and we're going to do a deep dive on those. So as we said, the first is a new wired assurance service. So as we said, we took the EX aggregation and access switches, we've moved it into the Mist cloud, we moved it into the Mist AI engine. So now all the benefits that you got on the wireless side, we also now give you on the wired side. And again, Sudheer and Bob Friday will talk about that. The second thing, as we said, we're going to talk about is the other announcement is Marvis Actions. So again, that self-driving framework for simplified operations and real actionable insight. Next thing, we actually have one of those marquee customers that I mentioned here, and we're going to bring them on stage. So Felix Went from Dartmouth is going to be here. They're a Juniper customer in both the switching and on the wireless side, and he's going to come in and talk about his journey and things that he's learned along the way and some of his use cases. As we mentioned, we're going to bring in our data scientist team, or our head data scientist, to do a deep dive there. And then we're going to talk about some automation. As we said, it's not just about day one, it's how you automate the rest of it. And then we're going to bring in a lot of those other really cool Wi-Fi things that we just never seem to get to. Things like guest access and policy configuration and things like that. And so then we'll take a little bit of a break, and then after that we'll move on to the SD branch side of the house, where we got Tony and Snehansu are going to come up here, and they're going to talk about CSO and give some use cases and a demo of the SD branch. Okay? So it's a lot, we know, but we're going to keep it entertaining, and that's why we're actually starting with Sudheer. I always make sure I go before Sudheer, because I cannot match his energy level. I think someone said when Sudheer talks, it's pretty much like, Mist, Mist. And so hopefully you'll get more out of that than that. So that having been said, let me hand it off to Sudheer and Bob, and we'll go from there. Thank you, guys.
Awesome. Good morning, and thank you for joining us. Really, really excited. I think the big news for us today is in under 6 months, we've brought the Mist AI engine over to the Juniper switching side, right? Again, there's a lot of Mickey Mouse AI solutions out there, and so what we are proud of is the framework that we've had at Mist is now applicable to the EX switching, and there's a whole journey here, and we're going to talk about it. So what we're going to do is actually we've been using the same slide deck for the last 4 years in terms of what it is that the journey we are on. And the journey has been about self-driving, right? And when we say self-driving, there's a lot of skepticism on, am I going to put my network in self-driving mode? Should we even use this thing? This is a very heavily overused term. And we're going to give you very tangible examples where we materially make people's networks better with the AI that comes out of this, right? So that's what you'll see a little bit in Jixing's presentation and the tail end of this one. So we're going to essentially use the same slides we've used for the last 4 years, the journey we've been on, but translate that to, okay, what does it mean to actually have, the Mist Marvis engine applied to wired switching, and how does that evolve? So Bob, without further ado, I'm going to ask you to sort of lead into the journey we've been on.
Yeah, no, so as Sudheer says, right, this has been a journey, and that's why the slide hasn't changed. We're very persistent, and we're being on the journey for the last 4 to 5 years. For me personally, this journey actually started back at my last startup, Aerospace, back in the early mid-2000s, because it was really during that adventure where I finally saw that we saw Wi-Fi go from a nice-to-have to a must-have. The other thing I saw during that adventure was really around seeing customers starting to put critical business services on their networks, right? This is where we went from watching customers who want to actually put some sort of mobile consumer app onto their network. And we also saw distribution centers, right, where people were relying on their networks to basically make sure product was shipping out the door every minute of the day, right? And if that network went down, their business stopped, things stopped shipping. So this is where we saw that paradigm shift really going from back in my Aerospace days when we were here to sell you a box, right? And it's like, here's a box, here's some management software to go with it. Really, the paradigm shift has really gone to, we need to actually help customers with this end-to-end user experience. Whether it's a consumer inside of their store that's trying to use an app, whether it's a barcode in the distribution center that's trying to read products. What customers want right now, they want help on how to manage the end-to-end experience of some device or some person. And that's when I realized that this AI stuff is really becoming more reality than hype. And so one of the other key inspirations for Mist was really around, for those who remember the Watson, this is my other classic story, for those who know me, when you saw Watson play Jeopardy, that is when I realized that if they can build something that can play championship level Jeopardy, we should be able to build something that can really answer questions on par with network domain experts. And that's the journey we've been on since we started Mist 4 years ago, is really to answer that question of why is a user having a connectivity problem? Why is a user, why can't I read that barcode? Why is that device not actually connecting to the network? Or why is it having problems? So that's where we started the journey. That journey started with data. If you look what in Mist here, that was the reason we started to build our own access points. It wasn't because I wanted to build yet another networking element. It was I wanted to make sure I can actually get the data that I need to answer that question. And with the Juniper acquisition now, what you're going to see is you're going to start to see Marvis and this AI ML engine start to be able to answer even more questions, right? When we brought in the access point, that gave us the ability to start really look at the connectivity. That was a key point in the network where you really can understand what's going on with someone's connectivity. When you look at the SD-WAN router and that piece of the puzzle, that really allows Marvis to start to answer questions like, why is a user having a video collaboration problem, right? Why is the app having a problem? So as you see Marvis evolve, it really starts with this data section, right? Being able to consume and ingest data from other parts of the network. And that's why the Juniper acquisition was such a critical step in the evolution of Marvis, because it's going to let us start to answer more questions, and it's going to let us start answering those questions with more granularity. When we start bringing the switch into Marvis, we'll start to be able to understand those VLAN problems now. And in addition to understanding them, we'll actually be able to start taking self-action and start correcting them, right? If we see a missing VLAN, we can actually fix that problem, right? With the IT administrator's approval, right? This is one of those, yes, we know you're missing a VLAN. Would you like me to fix it? Yes, please fix it and don't ask me again. I trust you now. So this is like any other person, right? IT people do not trust, you guys just inherently do not trust anyone to touch your network, whether it's a AI thing or a person thing, you just don't want anyone touching that thing.
I barely trust myself.
Yes. I know you're always scared. So should I push that button? There we go. Let's hope nothing goes wrong here. But that's where the data really comes important, right? You got to make sure you can actually get the data you need to answer whatever question you're trying to answer. The other key part of this adventure, and this is what I try to remind people, if you look what happened with Watson, if you read that story of Watson, that was a multi-year venture. That was 25 guys who spent 4, 5, 6 years trying to build something to play Jeopardy at championship level. We're about 4 years into the adventure right now. We're getting closer to playing championship level. But the neat key part is really this AI primitive section. It starts with data. It starts with data that's really based on user experience. And that's probably the other big difference between what I did 15 years ago and this time. 15 years ago, it was really about just managing that switch, that router, that access point. This time around, it's really about trying to manage the end user. So you got to keep track of the end user state, right? So that's what we're really starting with and we're aggregating the data from there. But the AI primitive section is really, once you have that data, now you have to put it into some form that you can apply data science to, right? And this is where we are actually, and this is where when you look at a Mist Juniper system now, usually one of the things we hear from customers, they have more visibility to more data than they've ever had before. That's because for Marvis to work, we have to get that data into the cloud. And once that data is in the cloud, then you have access to it, right? Marvis has access to it, you have access to it. So you can actually see what's going on. And as Jeff mentioned, the data science toolbox, it takes more than just one model. When you look at those self-driving cars, it's just not one algorithm that's driving that car, right? It's just not one algorithm that's playing Jeopardy. There's a multitude of algorithms to play championship level networking Jeopardy. You have to have multiple algorithms running in parallel, trying to answer and look at all the different possibilities that are going on, right? And then finally, you have to put a face on this, right? The goal here is to actually make this eventually the point where it's so easy that even your end user can figure out why is his connectivity working, right? Why is my Wi-Fi not working? Why is my internet connection not working? And so that's the ultimate goal, is to make this so easy that actually your end users can almost self-serve themselves at some point, Dave. And then finally, the action framework that Sudheer just announced, this is truly the beginnings of this first signs of self-driving, right? This is where we're getting to the point now, we know when there's a hardware problem, we know when there's a cable, we know when there's a missing VLAN. So now we're getting to the point where we can actually, with the IT administrator's approval, start letting Marvis actually issue those support tickets. So we're starting to have a few customers now who are letting Marvis actually generate the RMA tickets, right? They're trusting Marvis. Yes, I trust you that you've gotten that. If you tell me there's a broken piece of hardware out there, I'll trust you to generate the RMA. So we're just starting to see the beginnings of self-driving actually taking place in our customers. And those who know me, and this is an outstanding thing, if anybody wants to talk wireless over wine, I make a barrel of wine every year. Turns out that making wine is actually harder than wireless, believe it or not. I thought wireless was hard until I started trying to figure out how to make this wine stuff. But it truly does. Wine starts with great grapes. If you don't have good grapes, you're not going to get good wine. There's a lot of other things that can go wrong, but you got to at least have good grapes. Same is true with AI. And if you look at Mist, one of the things we did, try to get that user experience. Back in my aerospace days, it was about synchronous data. Every 10 seconds, we sent some data back, right? This time around, we have something called pace events, asynchronous events. So in addition to those pace events, and I think Mist was probably the first vendor that did this, we had asynchronous user state events, because we're keeping track of all the state of everyone connected to the network. You're really monitoring the state of the users or the devices on that network, right? And so that is where the data piece of the puzzle is. Your two things are happening. You have to have good data to get the answer, and you have to make sure you keep track of the end user state piece of the data. And when you look at where we're evolving Marvis to, with the Juniper acquisition, what you're going to see is start ingesting data from other sources, right? You'll start seeing us take data from the mobile devices and bring the mobile device view into the network. You'll see us start to do the IoT device discovery. If you look on your networks right now, probably you have more headless devices with no endpoint security on those devices, right? We'll start bringing that into Marvis and giving you better visibility onto those devices that you don't really secure, you really may not even know about around your network right now. And we'll start bringing data back in from the SD-WAN router, right? That will start giving us the capability to start giving us better granularity on the root cause. When a user has a problem, I know if it's a wireless problem now pretty well. With the view from the SD-WAN router, I will now be able to tell whether or not there's a WAN problem, right? Is there something going on in your WAN circuit? Did you fail over to your cellular backhaul? All those user complaints, is it because all of a sudden you had a failover that's starting to generate all those support tickets? So the data is probably the most critical thing going forward that we're really looking at. And with that, I'm going to turn over to Sudheer, because you really have to feel, you look at the data that we're actually storing away now. And this is a good example of what we're doing on the back end now and how much data we're storing per user.
Thank you. Yeah, so actually, if you think of, there's lots of clouds in the industry today from a lot of vendors. If you think of what those clouds actually all do, fundamentally, they took functions that are on-prem and moved them to the cloud. When we had a clean sheet of paper and opportunity, when Bob talks about, hey, asynchronous data is going to the cloud, what does that really mean? What that means is we are the first guys that actually what we did is every single state transition that's happening at the AP, almost actually every second you will see that going to the cloud, right? It's never been done in the industry. You can unravel any of the clouds in the world, any of the clouds from any of the vendors. Literally everything is in the cloud. And you'd think, whoa, that's a lot of data and my WAN pipes and stuff. What we've done is actually, in spite of sending all of this, we've compressed the data so much and made it differentials that we consume 2 kilobits per second per AP. Some of the largest deployments we have, maybe 10 kilobits per second per AP. But the idea is, once you have this kind of data in the cloud, it changes what you can do. Right? It truly changes. You can move the AI plane into the cloud, and you now have all of this data to be able to do, clustering and analysis in, right? This is what the fundamental difference is between what Mist is doing for wired and wireless to what we've done in the past with sort of the legacy cloud vendors. Right? So this is what became the foundation of sort of the Mist AI engine. Now, what we did then is we took each one of those, data elements, 150, almost 200 unique states, right? There's one way to connect to the network. You actually do, associate, authenticate, get DHCP, get DNS. You're off to the races. But there's, 150, 200 unique ways in which you can fail. We collect, collate, and curate all of that, and we are actually trying to do machine learning on this, right? So Bob, before I go into the demo of this, maybe talk a little bit about sort of the framework here.
Yeah, so this is a good example of that AI primitive framework we talked about. This framework was really built for something called mutual information, and it really was never intended for a user to actually see. But what we found is that the same information that Marvis needs to figure out what's wrong is the same information that our IT customers really like to see, right? That's that trust element. They want to know, how did Marvis get that answer? They want to see that raw data. So this is a framework in which we found the AI has forced us to really do the homework of getting an answer. And it really kind of automates what the same data that an IT user wants to see.
So what we did is when we collect every one of these user states and collect every state transition, literally you can pinpoint and say, hey, I want, in the wireless world, if you're doing an enterprise deployment, everything to be neg 66 dBm. Every user, every minute, we are actually asserting whether we are delivering that experience to the user or not. Right? Because this data exists. And so now, then we said, okay, if it's a connectivity issue, either you're taking too long to connect, you're not able to connect, or you're roaming. It's literally, every Wi-Fi connectivity issue is one of these three things. You're taking too long to connect, you're not able to connect because of credentials or whatever, or you're having some roaming issues. We can tell you exactly where that issue was happening, when did it start, and literally, this is what Bob was talking about, is who is it impacting? Right? So a very large warehouse customer we had, they pushed out a certificate to their Windows devices, and literally at 12 a.m., 12:01, their devices started to fail, right? And so, huge Fortune 100 company put the wrong year in the certificate and just caused a catastrophic failure. And so then you go into these individual devices that are failing, that were the affected devices, and we have something we call dynamic packet capture. So this is like having a video footage of every network crime being committed, right? So every time somebody fails, you don't have to say, hey, can you go recreate the scenario so I can figure out exactly what happened? The proof already exists, right? This is all wireless stuff. It's been there with Mist for a while. Now let me talk about what are we doing for the wired side of the equation. So this is brand new for us. And sort of being launched today. So obviously on the wireless side, we've had always these SLEs and service primitives. What data are we bringing in for the wired side? So I'm going to start with very basic stuff. Right? Essentially today on the Mist dashboard, if you went on the Mist dashboard, you would actually have, basically, Wi-Fi access point, and brand new today, what we're launching is you're able to onboard Juniper switches onto the Mist dashboard, right? So what does that mean? What that means is you can actually brownfield adopt any Juniper switch that is out there into the Mist dashboard. You could literally, you'd be pasting a few lines of CLI and saying, hey, you're now adopted by Mist, and so now the Juniper switches are coming into the Mist dashboard and establishing sort of a secure tunnel to the Mist cloud. So this is the starting point, right? This is where the switches are in the dashboard. Again, I'm going to start with basic stuff and build up to sort of the AI we've brought into this.
Sudheer,
yeah.
Is it any Juniper switch?
So, good question. So the Juniper switches, the currently shipping Juniper portfolio, anything that is out there, 2300, 3400, 4300s, and including the 4600s, yes, EX Juniper portfolio.
Right. Now, based on the command that you had set on there, just for simple SSH stuff,
yeah.
am I to assume that there is nothing yet built into the EX software for interacting with?
That's correct. That's correct. So we are
things on Marvis.
Correct. So essentially, let's say I'm a large university, been running Juniper switching for 4 years, without me having to upgrade lock, stock, and barrel either hardware or software. So we're saying anything Juno's 17.x or even 16.x on, which has open config and netconf enabled and reverse SSH enabled, we're able to bring them into the dashboard, right? Yeah.
And this may be getting ahead of the game, so feel free to tell me.
Yeah.
What are the plans as far as going into the MX, QFX, other areas?
Yeah, so actually, we will talk a little bit about that. So in general, we've been intently focused on the access layer, because if you go back to, Bob keeps reminding us every 5 minutes, we're here not to manage boxes. It's about user experience. And so when we started this journey, actually, I was questioning. We have a customer advisory board, about 50 or so customers, and we're like, guys, who needs this wired stuff? Don't you have enough solar winds and other stuff out there? What do you really want us to do? Right? And so the fundamental, for me, the aha moment, and first of all, isn't wired going away, isn't everything going to wireless, right? So these guys said, no, time out, not true. We have more wired devices today than just 2 years ago. And as a 20-year biased wireless guy, that was like, huh? What? And so he said, no, we have more IoT devices. There is absolutely more wired devices. Here's Mist what we want you to do. We don't want you to tell me if a switch is up and port is up and fan is good and PoE is up. We want you to tell us when I plug in an IoT device why it's not getting to its service, right? The whole notion of the pivot that we've had on the wireless side that is user experience based, that's what we're trying to bring to the wired side, right? And so so now for that reason, intentionally, we're starting at the access layer. But as you all know, if you've used Junos before, it's one Junos, and it's, very interesting, similar architecture if we wanted to adopt this. In fact, some of the other platforms have streaming telemetry and other stuff that we could use, right? So yes. So basically, once the switches are in the dashboard, here's actually something, before we even go into the Juniper side of the equation. One of the things that we've done for wired switching, before we even, mystified the Juniper switches, we said, what about the rest of the ecosystem of switches that are out there? So we said, hey, there is this, super cool protocol, super secret protocol called LLDP, and we could use that to actually understand the switching architecture that the Mist APs are connected to. So these 5 metrics actually came from a couple of our customers where they said, hey, we have a large Cisco wired footprint, and we want to understand how those switches are doing. So what are these 5 metrics? Number 1, switch AP affinity was, hey, they have about, I think 300,000 access points, something. In every individual unique location, they wanted no more than 12 access points per switch. Right? And today they manually correlate that, right? Go to every switch and says, which are you serving an AP on this port? Are we saying it? Literally they count that, and they just don't want the blast radius if a switch goes down to be so big that it'll take down an entire area. So we actually said, oh, you know what? Using LLDP, we could actually just tell you what the AP affinity is. So today, literally they use this metric via API and say, are any of my switches across my 5,000 locations serving more APs than I want them to? Quite simple. We could do this, right? Easy. PoE compliance are any of my switches actually underpowering any of the APs out there? And we're going to talk a little bit about missing VLAN, and let me explain the problem, and then, Jixing's going to explain the solution, right? If you do, a Cisco Flex Connect or an Aruba Instant or any other vendor where the VLANs are at the edge, like Meraki or even Mist, where the VLANs are at the edge, where near the AP, what happens is, if I have 4 SSIDs and 4 of them, let's just very simplistic case, have 4 VLANs, if one of those switch ports does not carry that VLAN, when a user goes under that AP, they're not able to get an IP address, but from a user's perspective, they'll say, hey, the Wi-Fi sucks because I walked under the AP and somehow my Wi-Fi drops, right? And after troubleshooting a lot, we realized, it's quite simple as that somebody didn't push a VLAN to that port, right? So that's a problem that's existed for 20 years, actually before autonomous APs, right? Now, we applied machine learning and AI to that very, very old school problem, and I'm going to let Jixing talk about what we did there, but really cool. And then simply, again, version number is in LLDP. We could actually say, are all your switches compliant on version? So this stuff works on any switching vendor that Mist is connected to. Now, but there are many instances where Mist APs are not deployed. And the remaining portion of the presentation is around if all there was a Juniper switch or a Juniper plus Mist as an example, then this is brand new, right? So we're actually bringing the switch ports in, we're bringing the switches into the Mist dashboard. This is basic stuff, right? Anybody can do this. But the point is we have to start here, and we're starting here. So you could actually go into any individual ports, port errors, port draw, bits, bytes, all of that stuff natively now in the Mist dashboard. So one of the cool things, again, as we progress this journey, is we are actually able to go into an individual switch and say, hey, we want to go, be able to look at the switch, right? So you can actually open a shell and go in and actually talk to the switch directly from the Mist cloud without being physically local on any of these switchable LANs, right? So all of this stuff is built in, right? So this, again, nothing here is earth-shattering. Everybody has to do this, and we're doing this, right? This is what we call, sort of the data phase of the journey. And then the last piece here is around bringing in wired clients, right? So being able to actually see, clients on the wired side connected on the switch port, blah, blah, blah. There's a bunch more detail here that's coming out. This is sort of the early phase renderings of this, right? So this is all base foundational data. The one good thing we found as we started this journey about 6 months ago was that Junos actually is very, very flexible and very rich in what data can be brought up, right? So this was sort of built up for us. So we have the data in the Mist dashboard now, right? Then what do we do? So what Bob talked about was AI primitives, data science toolbox, and sort of Marvis and other stuff. This has been an amazing, really cool algorithm. As a traditional controller product manager many moons ago, for me, AI is esoteric in terms of, AI, will it really help me? And these types of algorithms truly, have made me a believer. Bob, I want you to talk through this journey here.
Yeah, so this is a good example, right? When you look at AI and kind of when did AI really start to come into our mindset or on our radar? It was really around 2014. And there's a couple things that happened back 4 or 5 years ago, between the open source, compute storage, the data sets. But one of those things was really we started to be able to use these deep learning neural networks to solve problems. And we see that these neural networks and deep learning are really making a difference in our self-driving cars. They're making a difference in text and speech. So this is an example where we're seeing these deep learning networks really make a difference in our networking industry. And here it's making a difference in the area of anomaly detection. So anomaly detection is something we all talk about, and the problem with anomaly detection is it usually generates more noise than it's worth, right? You've got some anomaly detector that pretty soon you're waking up at 2 o'clock in the morning dealing with anomalies that are really not anomalies, right? So this is an example where when we started the journey, we started with moving average. It's about half the time, we get about half, but that's still a lot of noise, right? If I started generating a bunch of events to you, and you'd be like, hey, Bob, please don't call me anymore, I don't need you. We went to something called ARIMA, which is a fancier version of moving average. Got to about 80%. Hey, about 80% of the things we generated were real anomalies. But 20% is still a big number. That's still a lot of stuff to go filter through for an IT guy to go filter through. It wasn't until we got to something called LSTM, long short-term memory. This is a recurrent neural network. This isn't the type of neural networks they use for time series, text type of problems. Here we got to an example where we finally got to the point where we almost got close to 100%. So we had Sudheer mentioned a customer case study where we found 140 anomalies in one of our big customers. These are pre-connection anomalies. We gave it to him, and he verified, yes, all 140 anomalies were real. This is across a bunch of distribution centers that were all actionable that he was able to fix. So this is an example where anomaly detection, we're finally getting to a point where neural networks and deep learning is actually going to make a difference in our industry, in our network industry, where we're going to be able to use them to solve problems that are relevant to an IT administrator.
Right.
So with that, I'm going to turn it back to Sudheer.
Yeah, and this is just an example. So what is this? What is this anomaly that can take down 140 sites out of the 300 these guys have? Actually, it didn't take down their network. What they did is they had a planned PSK rollover for their handheld devices that they use in the store, and 140 store managers said, what the hell, right? And then next day morning, we were able to give them exactly where any one of these particular locations was, and who was having problems, and in which locations that they did not go impact, right? So the point is, as we went from the ARIMA model to the recurrent neural network model, the efficacy of AI is all that matters, right? If you think of what was done in the past, AI equals, AI in a very simplistic way could seem like, hey, it's just alerting, right? You're just telling me something. But what you use to get at that alerting is actually all that matters, right? So in the past world, whenever we saw a failure, we'd call out and say, there's a failure. In the new world, we'd say, hey, that's a failure, but is that a normal occurrence for a standard Saturday afternoon at that location, right? Being able to actually learn baseline and being able to say, and Jixing's going to go through this in the next section, that's what is game changing, right? So when you're looking at AI and the impact of AI and networking, the thing that you want to be razor focused on is efficacy, right? How many false positives are you actually bringing out, and how many false negatives, right? So false positive is when you woke some guy up when you didn't have to, and false negative is you should have woken up and you didn't, right? So false positives we've nearly eliminated. So when we say, and that's where, once you get to this high confidence level that you have near zero false positives, that's when you can actually go take an action. Yeah.
Okay, so here's kind of the trick question. So in order to do AI, we need events, big data. Okay,
Yeah.
so big data takes up space.
Right.
In order to have longer short-term memory,
Right.
that too is going to take up space.
Right.
So one is how long is that short-term memory lasting for? I'll assume it's a configurable event time, but what are the storage ramifications in that, and what options do we have for it? Because, everything such as storage is certainly not an unlimited asset.
Right. Jixing, if you can quickly grab Mike, I will let you answer that more credibly. But absolutely right? So it will take more memory. It will take a lot of compute and time. So maybe Jixing and Bob, what do you? How much data do we store? And maybe Bob.
I'll let you I would take a shot at this. If you look at the data storage right now, you look at every access point, looks like it's sending about 5 to 10 kbits per second. Looks like a Skype call, right? So we're sending about a Skype call's worth of data back to the cloud. All that data right now is being stored away into S3. And all that ginseng, I think on the LSTM model, we were basically looking back how many days?
Sorry, we use 30 days of the data to train the model for each site. I'm going to talk about details later. Actually, now we train one model for each customer, each site. And we end up managing more than 10,000 neural network models in our cloud now. So the model itself is not that big, but we are really managing, a lot of them to achieve the best efficacy.
Right.
Well, okay, and so going with your stat that you just came up with, so if I get 8 to 10 kilobits per second that I'm sending, that's 864 meg per day, per access point.
Right. Yeah. So we are storing
On your
about
client that has
half a billion, 500 million unique state transitions per day. Every day, about 500 million unique state transitions. And so, so the issue actually, here's our dichotomy, right? Here's our tough decision. We have to compete in the regular market like we are a Meraki or an Aruba. Yet we have a lot more cost basis here, and that's a decision we made. It is what it is, and so we're actually competing. If you look at in the marketplace, pricing wise, what you the consumer would pay or see, no different than a Meraki or an Aruba or Cisco. However, we incur a lot more cost basis into this. And so,
the good news is, I mean, there's two things here. One is the fact that we can even do it. Right, I mean, now I have unlimited compute compared to 15 years ago at Aerospace when I was dealing with the 1U Linux box, right? That's like, here, Bob, you can solve whatever fix in this box you can solve. Yeah, so we now have unlimited compute and storage. Yes, I am limited by my bill. Google, Amazon, yes, I get a monthly bill from these guys for compute and storage. The good news is storage is getting cheap. The data we store right now, I think we store data for how many months, customer data?
So customer data, we store this, for this model, they use 30 days, but we store about 3 months worth of data.
Right, and so we're basically storing 3 months worth of data, to your point, coming back, and that's all getting stored away in long-term storage. Okay. Good news is
you have no impact on cost basis because we are eating that. Yeah, sorry, go ahead.
But I understand that. But again, I'm trying to think long term for deploying this. So if I'm taking 30 days worth of that at 800 plus meg a day, that's about 25 gig for one access point over the course of 30 days.
So we have, like, as an example, and sorry, maybe let me let you finish your question. And your worry is?
Well, my worry is, again, the bill from Amazon or whatever it is that we're using in there for not necessarily the storage, but the compute and everything that goes along with it, because that is not exactly a finite resource.
Right.
Well, the bill that comes along with it, I guess, makes it so. But if that's one access point, if you're a large customer, you got 50,000 of them, that's a sizable chunk.
Correct.
Yeah.
Correct.
Now,
it is.
I would tell you it's cost effective. Now, I mean, I don't store 10 years worth of data right now. Basically, storing 3 months worth of data, coming back, each one of these is a Skype call. I'm storing away a Skype call for every endpoint.
Yeah.
That is cost effective.
But you're spot on. It's that data that makes all this difference.
Right.
And this is where, like, if you look at legacy architectures, right? If you take one of the other, cloud competitor who's been around for a long time, green color logo, they basically build a shard of 4 boxes. That is their 10,000 AP shard. That's it. That's what you get. And so when they actually had a customer, so on that 10,000 AP shard, let's say one customer is upgrading their images, other customer has an impact because they're constrained to that finite shard. What we've said is no. Our 50,000 AP customer has the exact same latency and jitter and user experience on the dashboard as our 5 AP customer.
But
because we're elastically scaling.
But to your point, right, that's in 2014, if you go look at why all this AI, ML started to happen, compute and storage hit a tipping point.
Yeah.
The cost got to a point where, okay, guys, there's other tipping points that got us going. TensorFlow, data sets got big enough. We got access to tools where the average person now can be a data scientist. It doesn't take a PhD anymore. So there's a lot of tipping points, but one of them was compute and storage hit a pricing point where, yes, we can actually do this. We can actually build stuff that actually is interesting AI stuff now.
Right.
Like Marvis, cost effectively.
So the next piece, what we've done, if you look at our journey was, data, AI primitives, data science toolbox, which is the anomaly detection. And the fourth pillar was Marvis, right? What is Marvis? Marvis is truly our AI engine that is basically a natural language response engine on just understanding and solving problems. The way Marvis is built is it's built to emulate the workflow of a human, right, of a network engineer. And so you could basically ask Marvis, hey, when a user calls in, when a site calls in, you could essentially ask Marvis, hey, what's wrong with an individual user? What's wrong with an individual site, right? So the idea here is when you ask the question, what's wrong with a particular site, we're piecing together the solution as if a network engineer was sitting there and asking the question, right? So what would we actually go troubleshoot? We'd say, hey, are the APs up and running? Is DHCP up and running? Is Radius doing well? Is RF doing okay, right? So fundamentally, eliminating subsystems that you don't have to go triage was step one, right? So now you say, okay, you're having some issues with authentication and Radius. Now let's go double click on and ask Marvis exactly what vectors were causing that variation and failure, right? And so here you can see, hey, of all my failures, most of them were authorization failures. These were the clients that were impacted. And again, to your point, being able to store away all of these variations of data is truly amazing. Abhi's phone, as an example, if you go troubleshoot, he's standing in the back of the room and we're saying, hey, your phone sucks because, it's client specific. It's not our, it's not a pervasive network issue. For us to get to literally those two words was 9 months of multiple algorithms to say, when a user calls in, is it systemic and everybody's experiencing? He seems to happen to be the guy that just happened to call, or is this specific to that device? That's a huge, segmentation on how you go about doing, the triaging. This one is truly customer driven for us. One of our very large customers essentially said, I want to proactively reach out to users that are unhappy. And we said, okay, we can ask who the unhappy users are, right? And so literally we would say, show me slow Wi-Fi users, or so show me unhappy users. And I'm not kidding. They literally, if they see this bar, we have 2 customers who we have a call every Wednesday, and literally they'd get on the call. All they would do is run the command and say, okay, let's go look at it. And they obviously were training them as they walk away and literally say, okay, what's wrong with Jody's iPhone? And they will say, oh yeah, this certificate, this VLAN, this DHCP, whatever, right? These kinds of things. So now unhappy users has become a go-to command for us on proactively seeking users. Not every IT team has time for it. Not every, you can't possibly do this in a university environment. But if you're an enterprise and you are passionate about users' experience, the example we always give is when we displaced a large Cisco deployment, about 1,200, 1,500 AP deployment in the enterprise space. They were about 100 user open support tickets per month. Per month, 100 users, actually, they're about a 20,000 AP and 20,000 user enterprise. 100 people would walk up to the tech lounge and say, hey, my Wi-Fi, something is wrong, right? So we said, and the CIO said, I'm going to go to Mist. Your story sounds a little too good to be true. I'm going to give you guys a shot, but I want that to be 0. I do not want 100 people walking up to a tech lounge and saying, my Wi-Fi is not good. So that's where we systemically went through, long story short, about 11 months into the deployment with Mist, that 100 user open support tickets went to 2. Wasn't 0, hard, but pretty close, right? So now let's talk about all of these constructs coming to the switching side. So number 1, service levels. So we will now have, wired service levels. This is actually a very early rendition, artist rendering of this. You will, in the next couple of weeks, you will actually see some more deep data coming through on the wired service levels. This is for wired users. As an example, so we are coming out with specifically 3 service levels. Not all are depicted here, but throughput as an example. We want to be able to say, if a wired user is having a bad user experience day, what could it be? What could impact wired user performance, right? So there are a few ways to do that. So number 1, let's say my uplink is congested, or my east-west traffic is congested, or I have interface errors, or my device actually negotiated down to 10100 when it's supposed to be a gig. There's all kinds of unique, interesting things that are happening on the wired side that we can, on a per user, per minute basis, collate and say, what is the experience of the wired IoT device that probably can't walk up to a tech lounge and open a support ticket, right? What is that experience? And why are these things interesting, right? I'll give you a very profound, interesting needle in a haystack example. We have a facility that has about 1,000 robots. The robots actually traverse 5 access points in under a minute. That's how fast these robots are moving, okay? 1,000 robots, and we're running this facility, and the SLE was saying 99%, right? It's like, okay, what is that 1%? So we went to, what is this 1% of users that are impacted? We found there were actually 4 robots in this affected items column. So this affected items column for us is actually, finds the sort of the needle in a haystack problems. And so we found 4 robots out of 1,000 were actually not getting good throughput and good coverage. We said, coverage is great for 996 of these things, and 4 of them are having an issue. Turns out, long story short, when they went and opened the robots, the wireless, radios and antennas were busted, and it's a miracle that they even connected, right? We find needle in a haystack problem. So why do we need service levels when you have all the data you have on your wired network today? The reason you need service levels is, number one, being able to easily identify which devices are not getting to the network, which devices are stuck, which devices are negotiating bad speeds. All this kind of stuff today happens on the wired side. It just happens to work because wired throughputs are high anyway. And so, people don't know unless it becomes a big problem. Right? So step one, what we're doing that is unique in the industry is being able to bring the Mist service level constructs on a per user, per port, wired basis on for the Juniper EX access switching, right? This is why we started with access. And again, this particular piece of the SLE demo, you'll actually see in the next about 3-4 weeks, this will transition to what I was talking about. The second piece we want to know in terms of service levels is why are users actually having issues, right? So this is where we come in and we say, okay, now Marvis has been expanded and extended to the Juniper EX switching. So you can actually ask, hey, basic stuff, show me the switches in the dashboard, show me the wired clients at this particular site. So Marvis is actually is now already decked up for wired networks, right? So for wired and wireless, one place, same interface, and be able to ask questions. Bob, I'm going to actually pause here, ask you to talk about sort of the framework of Marvis actions, and then we'll do the demo on actions.
Okay,
Yeah.
real quick before that.
Yes.
When we're looking at this on the wired side, because you had mentioned that user might have a problem because of east-west traffic or whatever,
Yeah.
and I kind of get to thinking of obviously troubleshooting wired network connectivity. Right. So with the information that you're getting, is Marvis's capability more on identifying which hosts are having issues or actually trying to diagnose what the actual issue is? Because the second one, at least in my mind, implies that you have the knowledge or the analysis expanded to the entire path, the entire transit path of packets. And I don't know whether that is or is not true in how we're looking at this.
Perfect. Great question. I think actually this should address that. So the idea.
What a great lead in that.
Thank you very much. I'll slip your $5 later.
Yeah. So, man,
You're welcome.
But I think if your question is, yes, if we're solving end-to-end problems, yes, we have to have data across the whole path, right? If I'm going from this device all the way to the internet, yeah, I'm trying to figure out why this device is having a problem. Now, it turns out that the access point has a lot of that information, at least the layer 2 stuff. So I have all the connection state information from that path there. Now, what I don't have is like all the layer 7 app stuff, right? That's why we need to bring the SD-WAN router, right? Because that element has a lot of the app service flow information. So that's where you're going to see us start to be able to answer more questions. Right now, when we started Mist, the question we're trying to answer is, why is this guy having a connectivity problem? That was kind of the fundamental question we started with. And this here kind of looks like, and my analogy is back to Watson. If you go read that story about how they figured out how to answer and play Jeopardy, what they found is that 10% of all Jeopardy questions can be answered with this a simple Google search, right?
Depends.
And that's really, you start to learn is when you want to play championship level networking Jeopardy, right? I'm trying to answer networking questions. I need to have different algorithms and different frameworks inside of Marvis here. And this is where you're starting to look at, we're starting to add more of those frameworks. You know, down here, you're starting to see us add AP health and switch health. That's where we're starting to bring in the switch information into Marvis that lets us start to be able to correlate config changes, right? I mean, one of the other famous customer stories we had is we went into POC, the customer called us up and said, hey, your wireless is not working. You guys, you know, the other guy's wireless worked, your guys didn't, the guy's about to get kicked out. He said, well, hold it, let me go, you know, let me get Marvis figured. Anyway, after about an hour of looking at Marvis and trying to see what happened is they basically had changed the config on a router, right? And so yes, to answer those questions, I need to bring in this timeline framework, right? I need to bring in an event framework that lets me correlate a user problem with a config change, right? And so that tends to help answer all those type of problems, right? You know, and it turns out that the config changes, I don't know what percentage of network support tickets are, it's above 10%. I can tell you how many times people, to your point, right? Someone pushes a button, they don't realize that they've just broken something. In our case, it was someone had basically changed the MTU size in a router, right? So that router would not pass large MTUs anymore. So the authentications were failing because the authentication packets were bigger than the MTU size would allow to get through. So this is an example of, this is the framework that Ginseng's going to go more deeper on. Or keep adding to this framework so that we can get closer to championship level Jeopardy. This is the framework where we're basically starting to bring the user, the IT user into the picture, right? Over here, we're looking for root cause, right? We're looking for why is the user having a problem? Why is this AP disconnected? Why is they switched down? As we get into the SD-WAN router piece of it, that's when we're going to be starting to answer different questions like why is that application having a problem, right? Why is your Zoom user having a problem? You know, so this is the framework that lets us get to root cause. Those root causes, once we get to this piece here, you know, once we get to like right now, 90%, with 90% confidence, I can probably tell you whether or not you have an Ethernet cable problem or a hardware problem. So the user can now make a decision of, is 90% good enough? Should we let Marvis generate an RMA ticket? Now, in this case, I think most of our customers are saying, hey, 90% is for a cable change. Yes, I'll let someone go change that cable. And if that fixes the problem, that's great. If it doesn't, Marvis will come back and let you know that, yes, the problem's still there. You know, so this is an example where we are starting to take the beginnings of self-driving. Marvis is starting to take actions. A lot of these actions are either a ticket, an RMA ticket or a support ticket of some sort, or it's an action that we can take like a VLAN. In the case of Juniper now, where we have access to the switch, if we know there's a missing VLAN, we can plumb that. You give Marvis permission, Marvis can actually start plumbing that by himself. So this is where we're excited really about this. You know, on this journey where we're at, we're getting very close to playing championship level Jeopardy. We have enough information now from enough different sources where we can start answering, why are you having a connectivity problem? Why are you having a poor internet experience? You know, and we're getting close to it being 60% correct now on answering those type of questions. With that,
Yeah, we'll quickly, sorry, go ahead.
Cool, what's up?
So actually, let me go back and quickly finish the demo on Marvis Actions. And so what Marvis Actions ultimately is basically the way I want you to think about it is, today, the way problems work out is users complain, then IT has to troubleshoot, and then, you know, at the very end of that troubleshooting session is a human action, whether that's changing config, upgrading image, replacing hardware, whatever. So we want to cut all of this run up and just get you to that human action. If we can fix it, we're going to fix it. If it's in an adjacent system, we want you to actually take action. So today, across a system of about 50, 60,000 APs, across actually the 50,000 AP network, we found 19 APs in 50,000 had a missing user VLAN, right? And that was a sort of a needle in a haystack problem. And so as soon as, basically Marvis bubbled up an action saying, hey, 19 of them had a missing VLAN, they came back and said, absolutely, all of them were true, right? So we were able to literally, in a very, very large network, be able to find needle in a haystack problem. Now translating that to the wired stuff, what you're seeing now is this is the integration with the Juniper side, is being able to actually see if a cable is bad. Making an assertion that, hey, we believe there's a 90% chance, like Bob was saying, that a particular cable is bad. We've actually done a deployment of about 12,000 APs at a retail location, 2,200 locations, and we found a bunch of them on their existing switching were actually negotiating to the wrong speed, 10,100. So they said, hey, could you just let us know if any of our devices are negotiating to a non-gigabit Ethernet speed, right? Literally, we were able to bubble up in Marvis actions the entire thing. The framework, this framework was what Bob was talking about, leads to, is we today map to, be able to map to whether if there is a software issue on an AP, right? Believe it or not, some software engineers write bugs. And if you ask Lee Badman, there's a lot of them, right? When we say we are self-driving, we today are able to detect even software issues and remediate them without human intervention. If a radio is stuck, a beacon is not transmitting, if broadcast multicast is stuck, has happened in wireless for many moons, we are with high efficacy detecting that. Let's say a radio is stuck, right? You could say, there's no clients, no traffic. Is that radio stuck? Or you could say, there's no clients, no traffic, and all these other vectors actually match. So that is a fingerprint of a radio that is stuck. So when we say we're putting things in self-driving mode, we're actually, remediating and making networks better without human intervention. And this driver assist comes in when it's an adjacent system, right? So I know, Bob, we are very, very late. We are 15 minutes over. So the next two slides, if you could do quickly.
Okay, so this one we did. So we'll do this one quick. So this point of this slide is, for those who know me, I was at Cisco for 8 years or so. When I started Mist, as soon as I started Mist, they were like, Bob, you're crazy. Why would you ever start another wireless company? The market's mature. There's plenty of players in here. What this highlights was really, the reason we started Mist was because fundamentally, I believe there was a new architecture that would do a much better job at managing these networks, right? And that architectural change started with the modern cloud stack. Because when I looked at what was happening on the cloud side, the modern cloud stack is fundamentally just a better way to maintain and develop software. And this is really around the speed, right? This is really around how fast can you modify. You ask me to fix a bug or change a feature, it doesn't take me a year anymore. The architecture will allow me to fix that next week time frame. And when you actually want to solve an AI ML problem, you want things to go real time. That was the other architectural change that's happening, right? People don't want to manage their network elements anymore passively. They want something that can ingest data real time. And then to your point, right, that's the other transition that happened architecturally. The storage and the compute has got cost effectively enough. When you look at what we're storing, it's relatively small compared to what other people are doing right now with these data pipelines. So that was the one big thing is data architecture. Organizationally, the other thing that told me that there was a fundamental change happening in the industry right now, and I saw this when Cisco acquired my last company, Aerospace, right? When you see organizations trying to pull together different business units to solve a problem, that's usually a sign that something's happening architecturally somewhere. And when I solved the AI ops problem, what I learned, similar to what we saw in the cloud world, right? When you tell it to build these large cloud applications, you need to get dev and ops working, the development team and the op team need to be tied together. It's really great. Where does cloud operation end and dev begin? Same with AI ops. So at Mist right now, Jinsing, who's here, Jinsing's our head of data science. He is working side by side with our customer success team. So every time one of our customers, right, that data is going into the cloud, our customer success team sees the same data almost instantly now, right? And that's why he can call up the customer and say, hey, you have a problem, heads up, right? Usually our success team, our customer success team almost knows there's a problem before our customer knows there's a problem because he's keeping an eye on it. And he is basically telling Jinsing, here's what I need. Here's the problem I need you to apply data science and AI ML to, right? Because inherently data science guys do not know their domain problem. So this is really the domain piece of it. And so what I would claim is that, if you look at what Mist Juniper is doing right now, we are currently the only infrastructure vendor that's currently using its own AI ML to actually answer every support ticket that comes in. We basically use Marvis to try to answer that support ticket. And what that leads to is this. For the last year, we've been using Marvis to answer every support ticket coming in. And what this graph highlights is, over the last year, these orange bars indicate how often did I have the data in the cloud. Because for Marvis to answer a question, the data has got to be available. If the data is still stuck out in a switch or an AP, I can't answer the question. Marvis can't answer the question. The question has got to be somewhere in the cloud. And that's why our customers, when they work with Mist, they start to get the visibility they haven't had before. And that's because for Marvis to answer a question, I got to get that data in the cloud. And once it's in the cloud, you have access to it. You have access to the same data that Marvis has access to. Now, these bars down here represent how often did Marvis actually help an IT support person answer the ticket. And this is what we call championship level. And this is where we are on the journey right now. We're right now kind of in the halfway point. About half the time, Marvis helped the IT guy get to the answer, or get to the answer quicker. And so my goal right now is, to get to championship level, I want to get this up here. Small, big, right? And so we are very close to playing what I call championship wireless Jeopardy, right? And this is the fundamental change. I think you started to realize, I think one of you, this is about end-to-end user experience. When you look at your AI ops layer, this layer here, this is going end-to-end, right? We're looking for end-to-end user experiences, and you have to architecturally make sure you have an architecture that can support your AI ops layer, and you have to make sure you have an organization that can support it, right? Because we're not going across silos, right? Even in the IT departments, there's usually someone who takes care of the switch, someone takes care of it. You need to start thinking broader, right? You need an architecture and an organization that can solve end-to-end problems going farther.
Hey, Bob, can you go back to the last slide with the graph?
Oh. Next one.
You go the right way. Ooh.
What do you think would explain the variance? Like, why 1 month 50% with Marvis and the next month it drops?
Yeah.
Is it like maybe new code comes out and things get a little wonky or something?
This is very granular. What you're seeing here is week to week, right?
Okay.
Right now, Jinsing gets together with the system. Every week we look at the tickets, and the tickets change from week to week. Sometimes whatever the support tickets we have. The other interesting trend is our customers start using Marvis. They start taking care of the easy problems, right? And so Jinsing claims that I keep raising the bar apart.
Are not the same as tickets here.
Right.
They've solved the problems. They can now fix it themselves.
Right.
And they're moving forward, right?
So the problems that
We've given him an unachievable bar.
So when I hired Jinsing, I told
more and more you
Jinsing-
guys are solving more problems. So the
It
problems
becomes
that
harder and harder.
yeah.
Another interesting is why we're moving to the self-driving. Sometimes we fix problems. So users don't have to even ask questions. Like Sudheer said, the low-hanging fruit become less and less while we're going on this journey.